Good morning, engineers. I'm going to record a worked solution to one of the questions in the document that I sent you and then leave you to answer question one. Okay, so let's have a read of the question. It says, the diagram shows a steel plate used to connect three steel ropes that are in tension. The plate is in static equilibrium. That means that the sum of the forces is going to be zero. So let's have a look at the three forces. We've got 200 newtons up there. We've got 200 newtons there acting at an angle. And this is the unknown force with an unknown angle there. Well, let's start off with the fact that vertical forces sum to zero. So the vertical forces are this force up here, 200 newtons. This one is going down, our unknown vertical force. And then we've got another force going down there, and they're going to make zero. Well, this force here I can actually work out as being 200 sine 66 using the angle facts that we used last week. If I rearrange this, I'm going to get the fact that FV is equal to 200 minus 200 sine 66. And if I type that into my calculator, that's going to come out as 17.3 newtons. If I then look at horizontal forces sum to zero, I'm going to be able to say that this unknown horizontal force here is equal to the horizontal component of that force, which is, of course, 200 cos 66. And sticking that into my calculator is going to come out as 81.3 newtons. Now, I've got vertical force and horizontal force here, but I've not finished. I can use Pythagoras because these two forces are at right angles. And sticking that into my calculator, I'm going to come out with the fact that that is 83.2 newtons. And then I want to know the angle. And just like we did last week and the week before, I'm going to use opposite side over adjacent side, and that comes out as 12 degrees. So I've worked out the magnitude of the force, and I've worked out the angle of the force from the horizontal. I'm going to leave you, so I've got question one in that document. Don't forget to email me with any questions and email me your solutions.